Drum tuning manually can be a very tedious process. User usually would have to adjust each individual tension rod to achieve even sound throughout. This is the process that takes time and experience.
Our plan is to automate the drum tuning process in a way that is easy and precise. We want to ensure that the device can achieve a variety of notes while being user-friendly. Additionally, the device should be energy efficient, and its mechanical parts should last for the drum's lifetime.
This is how we start.
Here are the design goals for the CAD. First and foremost, you need to securely retain the motor, rotary encoder, and spool. The parts needed to have a bare bones design to make them easy to machine and make good use of our materials. The mount needed to allow for easy access to the spool for the fishing line, and it couldn't be too heavy as to not throw off the balance of the drum.
So what we did was we took out these fixtures here in your standard snare drum, which are screwed in. So we took the screws out. The fixtures hold the tension rods in, which tighten or loosen the heads, which cause a higher for tight, lower for loose note. So we took out the screws and we filled the holes in with some wooden dowels, which we cut to fit, and then we glued them in there. And so we ended up with this here.
Here's a pseudocode flowchart of the desired tuning process. First, an initial target frequency signal is sent to a microcontroller. This frequency signal also corresponds to a motor angle. The microcontroller tells the motor to increase the target motor angle until it's met. Then a drum signal needs to be applied to test the frequency of the drum head against the desired frequency. Tested frequency is within the desired range, stop testing and display the results. If not, then the motor will turn by smaller increments, either clockwise or counterclockwise, depending on which side of the desired range, above or below, that the tested frequency is on. This starts the process back over again. Shown here is a control diagram used to help simulate the process. As you can see, we have two feedback loops involving PID controllers. Here is an almost identical diagram in Simulink that shows the control of the system. This angle position selection is modeled using a step input, and the drum hit signal is modeled using a higher frequency signal. Shown here is our final output.
With the control analysis, we can implement those PID parameters to program the angle position of the motor as well as the vibration measurements. The motor displayed on the schematic here is connected to a rotary encoder capable of 600 pulses per revolution. And when they're connected to this H-bridge motor driver, the DC motor can replicate the behavior of a stepper motor without requiring any constant power. With this application, the motor can turn our pulley systems clockwise or counterclockwise at very fine steps. This schematic here also shows that the user can choose a fundamental note that they want to play using a potentiometer dial and an LCD screen, which would activate the speaker that is connected to the system and attached to the center of the drum membrane. The PZT sensors will then measure the vibration and evaluate data as sound frequency. This is done by performing Fast Fourier Transform algorithm. This is an example that shows we collect piezoelectric output, then modify it through FFT so that we have the current frequency of the drum.
To conclude, the self-locking motor and rechargeable battery help the device to be energy efficient. The highly durable mechanical components employed ensure that replacements won't be necessary. Additionally, our CAD models can be easily machined and installed, and the device can be easily operated. Also, our controls testing resulted in effective transient responses. Overall, we believe our device can be of great use for any drummer, especially those who are new to the instrument. Hi, I'm Alex Lee. I'm the CAD design and analysis lead for the SVAC Drum Tuning System.
Hi folks, my name is Stuart Matznick. I'm a fabrication lead for the SVAC Drum Tuning device. Thank you.
Hello, my name is Vancy Nguyen. I am the electrical and programming lead for SVAC Drum Tuning System.
Hello, my name is Watkins, and I am the control and transmission lead for the SVAC Drum Tuning System.